Hey guys, it's Mr. O'Shea. Today we're going to be doing an extension of what we did in class, lesson 3.2, which is going to be the opposite of 3.1. In 3.1 we were proving angles were congruent using parallel lines. This time around we're actually going to prove lines are parallel. So it's going to be kind of a flipped idea. Now, in class we talked about the corresponding angles postulate, being that if you have parallel lines, then corresponding angles are congruent. This time we're going to flip it and we're going to talk about the converse. So instead of if parallel lines then corresponding are congruent, this time around we're going to say if two lines and a transversal form corresponding angles that are congruent, so corresponding angles that are congruent, then the two lines are parallel. So before we had if two lines are parallel, then corresponding are congruent. This time around we're going to flip it and say if two corresponding angles are congruent, then you have parallel lines. All right, the converse of the alternate interior angle, same idea. If, we're going to write out the full definition for these. We could just skip and kind of say if alternate interior angles are, but we're going to go ahead and write out if two lines and a transversal form alternate interior angles. Remember, those are on the inside and on the opposite side of the transversal. If they form alternate interior angles that are congruent, well then those two lines, well, they're parallel. Okay, so again, we flipped the alternate interior angle theory that we learned today in class and reversed it, the converse of it. So the converse of the alternate exterior angles. This time around we got if, and now we're not going to write out if two lines and a transversal form. We're just going to say if alternate exterior angles are congruent, then two lines are parallel. And notice that little symbol, just meaning parallel. We didn't need to write out the whole if two lines and a transversal form alternate exterior angles that are congruent. I just kind of shortened it up. Now, the full definition would be all that, but just for our sake, we're just shortening it up a little bit. Okay, the converse of the same side interior angles. So if same side interior angles are supplementary, and remember that the S for supplementary, not congruent in this case. If same side interior angles are supplementary, then the two lines are parallel. I think a really easy way to remember that is all the S's that you have. S, S, same side. You can think of S, supplementary. That's how I always think of it. So, converse of the same side exterior angles. If same side exterior angles are supplementary, same side, supplementary. If those angles are supplementary, then, again, you have parallel lines. All right, so let's go ahead and use this. And remember, like I said, the easiest way to think of this is S same side supplementary. I do have to make one quick note, guys. You guys have this diagram in your packets. I made an error on there. Couple of things. Let's get rid of where those letters are, because I can't actually tell with the letters written like they are. I can't tell which line's which. So we're going to rename it. So that's going to be line C. That'll be line D. That will be line E and line K. All right, so angle 1 is congruent to angle 2. When I wrote angle 2 in the wrong spot, sorry about that. What can you tell me if that's true? Well, angle 1's here, and angle 2's here. I first want to look what transversal they're on, and they're on D. D is the transversal. So after you establish what the transversal is, then start looking for which lines actually make up the angles, and that would be E and K. So I can say that if angle 1 is congruent to angle 2, then those two lines are parallel. And those are alternate interior angles. So if alternate interior angles are congruent, then parallel lines. So your answer was E is parallel to K. Your reason was if alternate interior angles are congruent, then two lines are parallel. All right, so now I told you, oh, we got to switch that 2 again, sorry. Now I'm telling you that angle 3 and angle 2 are supplementary. What can we learn off of that? So we got angle 3 and angle 2. Immediately we want to figure out which transversal are they on. And they share K. So K is my transversal, which means my two parallel lines are going to be C and D. Now angle 3 and angle 2, those are same side exterior angles. And I know that if same side exterior angles are supplementary, which they were in the problem, then I have parallel lines. So we can prove that C is parallel to D because angle 3 and angle 2 are supplementary. All right, now if I asked you guys, are lines A and B parallel? Well, we've got that angle here and this one here for 148. They're both on the transversal going across. We'll call it T. Angle 32 and angle 48, those are, looks like they are same side interior angles. And whenever same side interior angles add up to 180, they're supplementary. So I know if same side interior angles are supplementary, then two lines are parallel. So my answer to that question would have been yes. Are lines A and B parallel this time? Well, here's the problem. When I look for the transversal, I don't really have one. Those are vertical angles. It actually doesn't matter what A is, those angles will still be vertical. I can switch A, I can kind of rotate it, right? Those 148s didn't matter, and we can clearly tell that those are not parallel lines. So if we're just dealing with vertical angles there, I'm going to say no, it's not enough information. We don't have alternate exterior, interior, or anything like that. They're just vertical. All right, example C. In this problem, we want to go ahead and find a value for x that makes those lines parallel. Well, if we look at those two angles, I've got 40 and 2x plus 6. I know that those are corresponding angles, so I know they're congruent, which means corresponding is congruent. 2x plus 6 has to equal 40, or 40 has to equal 2x plus 6. So we'll subtract 6 on both sides, and then we will divide by 2. So that tells me that if I want those lines to be parallel, x has to be 17. that's the value that would make both of those angles 40 degrees. And corresponding angles are congruent when you have parallel lines, so x has to be 17. All right, same problem, same idea. What does x have to be in order for those two lines to be parallel? Well, those two angles that we're dealing with there are same side interior angles. So same side interior have to be supplementary, same side interior. That means they have to add to 180. So I could say 7x minus 8 plus 62 equals 180. I'm going to get rid of, add an 8 on both sides. Oh, we'll actually combine those, sorry. Negative 8 and 62 gives me 54. So I've got 7x. We'll subtract 54 on both sides. We get 126. And then we divide each side by 7. You get x equals 18. X has to be 18 in order for those two lines to be parallel. Okay, now we've got another drawing here. I want to know what value for x makes L and M parallel. Well, this piece in the middle here has nothing to do with the problem. It's there to kind of throw us off. That, if we deleted it, that one angle on the left is still 105. The one angle on the right is still 3x minus 18. We don't care about that transverse, or that line. So you guys don't have the luxury of just clicking on it and deleting it, but you can still do kind of the same idea. Pretend that it's not there, because it doesn't really matter to our problem. How can I prove L and M are parallel? Well, I've got alternate. Oh, wait a second. I don't have interior angles. I don't have exterior angles. So what kind of angles do I have? Not really a name for these. But I could use the corresponding angles idea. That if that one's 105, its corresponding angle also has to be 105. Now I can go so far as to say that, well, 105 and 3x minus 18, those two have to make a straight line. They're supplementary, so they have to add up to 180. So just because there isn't a specific name for them, sometimes we can still use it. We've got 3x minus 18 plus 105 has to equal 180. So let's do the math here. I've got 3x. I'm going to add 18 to both sides, 198. I will subtract 105 from both sides. So I get 93. And then I'll divide 3 on both sides and I get x equals 31. So x has to be 31 for those two lines to be parallel. Alright, have a fantastic day, guys. Hopefully if you have any questions, please do not hesitate to ask. See ya.